Hello and welcome to Phoenix LiNAR Systems demonstration of SpatialExplorer 6. Today we're going to be highlighting the export features from our point cloud in regards to maps, contours, surfaces, and a project report. So let's jump into our point cloud here. That has its ground control points that have been used to vertically align our point cloud, as well as classification and RGB values contained. So if we navigate to our point cloud over here, where we found our other tools to manipulate this cloud, and let's jump into our maps section. Many different maps that we can create from this point cloud. These are just raster representations of different features contained within the point cloud. This could be the point density, the index of these strips or flight lines, as well as the overlap of those. Our geodetic altitude, so absolute altitude of our point cloud, as well as the height above ground, intensity, color, classification, distance to model, as well as height above ground. So all of these maps, let's just select them all to output all of them. We can set a custom resolution, pixels, number of pixels for the raster. We're going to stick with our default, as well as the point classes that are going to be used as input for these maps. Now, point class of all works pretty well for pretty much all of these. Perhaps maybe some of the absolute altitude, in which we could export a DEM surface of simply the ground model. Now, our interpolation here, we're able to do a local, like a number of pixels, or a global in terms of a more unit-based interpolation of where ground may be missing. So, for instance, this black runway here that did not get captured, we can allow this to triangulate over. So simple as that to select maps of desire, your input classes that are going to be used, as well as your resolution and interpolation size. So we can go ahead and hit OK and let that go. Now that our maps are created, let's go ahead and take a quick look at them. Turn off our point cloud and our ground control array. And let's turn all these off. Start looking at these one by one. You can see our density, our relative point density here, as well as our index of which flight line, strip index, or strip overlap, so the number of strips that overlap a certain area. All right, altitude, obviously, you can see our trees and our higher bank up here. Similar height, but more equalized on the top to bottom of the point cloud. Our intensity ranges, obviously our color map, classification map, as you saw before. Classification map looking from the bottom up, so the ground is more apparent, and the distance to model, so how much lack of precision there is. So these outside edges have a lot of weirdness to them. So now that we've made those maps off our point cloud, let's go ahead and produce something else too. Since we have classified our point cloud with ground, let's go ahead and use that ground classification to create some contours. So here in if we go down to our point cloud, in the Create Contours tool, it allows us to create contours really with any interval and any smoothness. The grid size is how large of a square area the algorithm will use to create the contours. The smaller the grid size, the more precise or noisy these contours can be. A very large grid size makes pretty long, smooth type contours. And of course our altitude steps, so the contour index. We're going to keep that at, let's go to the ½ meter, because there's not a whole lot of terrain here. And we'll keep our grid step, let's say at 3 meters, as there's not a whole lot of terrain change here. And as well as a hole filling radius, so triangulating across holes. And while we could create contours of everything, including trees and unclassified areas, let's just use ground, as that seems more applicable. And we'll go ahead and let that go. And you can see our contours are created quite quickly and easily, showing all the different terrain changes here. This is almost perfectly flat in here, so that's why we're not seeing anything there. You can see the bank rising up to that wall, as well as our high spot here. So we've created some different raster images of different qualities of our point cloud, as well as a geometry of contours, all of which are easily exportable with our little save button here. And another output we can use from this point cloud and the processing we've done, as well as our ground control, are a variety of reports. So let's go ahead and save a report for this project. And go ahead and let it save in there. And we're going to allow it to use our point cloud, as well as our intervals, to create project report. Here we could create the same maps that we had before in the report, but I'm going to go ahead and say none since we've already made those. And there's a variety of parameters and inputs that can be used for this report, including the acquisition, how the data processing and accuracy to ground control. And we can also create a processing report. Kind of shows us what the actual hardware in the system, the processing time and types, as well as our calibration of the LiDAR and trajectory point cloud statistics. We're going to go ahead and let that go. Now that our reports are created, let's take a peek. Here in our project report, we have a general overview, as well as the acquisition hardware, and the data processing, datum, epoch, etc. Here, our relative accuracy was already taken care of with our LiDAR snap report, but here our absolute accuracy is far more important. Here our RMSEZ comes to 2.7 centimeters, with other statistics as well. And you can see the exact report from our checkpoints, as well as the control that was used to calculate the offset, and a histogram of all of that as well. Here in our processing report, we have our camera and LiDAR information, all the calibration values of each laser within our HDL32, as well as acquisition specs. And down here we also have point cloud statistics in terms of points per second for each point in the trajectory, as well as reflectance values and the point count therein. And at the very bottom we have a quick report about our trajectory, highlighting our optimized 11.4 centimeter up for our optimized trajectory from LiDAR Snap 4, and graphs thereof. So from here, we can see we have many outputs, quantitative, visual, as well as point cloud that can be taken from SpatialExplorer 6 and used in your reporting and deliverables for your client, internal or external. Thanks so much for joining us, and I look forward to seeing you in other modules.